Hughes. I'm a data analyst at Montgomery Parks. A little bit about myself, since I think things got lost at some point. Esri portal. I'm a data analyst for about a year now. I made a transition to that from GIS, where I started at the organization at my first years. Starting to implement projects such as this that focus on like condition ratings and asset management, since my group administers both GIS and asset management for the organization. We're also moving into things like visitation, for which I'm project leading on, and there's a lot of exciting opportunities that I've had the opportunity to work with at the Parks Department, and this is one of my favorites. I definitely, and Brian, I appreciate everyone making the trek up here. It's a little hotter a bit later in this week, and it's quite far if you're coming from the other side of the conference. The presentation we have is about transforming a program incrementally throughout the years. I was not a participant with it this entire lifetime because of my youthful start in the program compared to Brian. But Brian has been there from the start, and he has a lot of experience and knowledge to share with how this has improved from quite literally paper processes all the way through the days of collector, and now with field maps and everything that's now afforded with like the modernizing of the technology that Esri affords us now today. I'll hand it off to you, Brian.
Okay, Montgomery Parks is part of the Maryland National Capital Park and Planning Commission. It's a bi-county agency that was established in 1927 with Prince George's County, Maryland. It was created by an act of the Maryland General Assembly. It's located in the suburbs of Washington, D.C. Our goal is to conserve and protect the stream valleys and the natural resources. Montgomery Parks is the largest landowner in Montgomery County. We own 58 of 507 square miles, or about 11%. Its population is a little over 1 million people, and we own 270 miles of natural surface and hard surface trails. Our drainage from the stream valley parks enters into the Chesapeake Bay. And a little bit about the Chesapeake Bay. It's the largest estuary in the United States. An estuary is a partial body of water that fresh water from the streams mixes with the salt water from the oceans. This watershed for the Chesapeake Bay, as you can see in this map here, it includes 6 states: New York, Pennsylvania, Delaware, Maryland, West Virginia, Virginia, and the District of Columbia. And its total drainage area is 64,000 square miles. So the scope of the program: all pedestrian and vehicular bridges, natural surface trail bridges, boardwalks, culverts. That all are included in this program. And a culvert is simply an opening under a road or a trail that a conduit for water passes through, and it passes through safely without eroding away the soil or collapsing. And they're usually made of a pipe that's usually circular or a box shape. So our program monitors these that are 24 inches and greater. All these green dots here represent one of those type of structures. But before GIS, obviously we were a paper system. Our inspectors log the information on a 7-page form for each structure. The trouble with this is we didn't have a complete inventory. These assets took a very long time to analyze, and our inspectors and staff, it was difficult for them to locate the structures every year as they went out. So we would use latitude and longitude data. We generally got that from older atlas maps. I'm not sure if everybody's familiar with the Alexander Drafting Company, but they were called ADC maps that started back in 1956, and they were created for the eastern United States, and they were county-based for every state. So we would use that, or we would use some distances or a mile marker from a post from a road off the trail. So the inspectors would also go out and record the ratings for each structure. And this was very important to us because this identifies whether the structure needs maintenance, repairs, or replacement. So here's our rating system. We rate things from 0 to 5, obviously 5 being the best and 0 being the worst. 5 is excellent to very good, 4 is typical 1 eminence area, and 0 we have totally closed. So you see in this picture right here that when we found this culvert, we had to immediately close it. Basically what happened over the years is the bottom kind of just like delaminated away, and the river or stream just basically dropped and eroded underneath the structure. This is very unsafe condition, so we had to immediately close this trail and remove this structure. We protected the side banks of this stream with large stones called riprap, and we're still waiting to replace the structure across into the bridge, but we are replacing this one. So here are some examples, other examples of some of our assessments. The picture on the left, you see a pedestrian structure that's supported by steel. Basically, this steel member here, you can see some delamination and you can see some pitting in the steel, but this steel structure here still is very supportive of the structure, so we rate that as a number 3, fair to poor. And then the structure on the right-hand side is a fiberglass pedestrian bridge, and it was just installed, so obviously it gets a rating number 5. So basically, we worked with GIS staff over the course of about 4 months. And we placed attribute information into our GIS system. This attribute consisted of basically what type of structure we had, for culverts, what length and diameter it was, and what material it was made of. And we created a layer that could be loaded up into the GIS system. We started with ArcGIS Collector, and the team consisted of inspectors and myself. We went out and for about 4 months' time, and we basically found all the bridge structures we could possibly find. And there, if you see the map on the right, they're all shown with a little square orange symbol. Basically, when we went through and we found 200 known assets in the beginning. And then basically as we went through, that increased by about 325% on the first year because we found approximately 600 at that point. Now today we have about 800 assets currently in this program. Now this is good because this provides us with a geo-reference point for all our structures. We can enter that into our Enterprise Asset Management System, which is EAM, and the EAM staff could assign a work order for the team, and they could go out and use the ArcGIS collector to find the structure more quickly in the field. So our initial successes of this. Obviously, it improved our ability to share our inventory between our EAM program and provide a fuller picture of what we have. We can now track and maintain our structures and create better operating budgets. The GIS also located the structures, obviously, for our inspectors to get there quicker and also identify what maintenance and repairs needed to be done. And it established a new process for us when we found bridges in the field, and obviously the workload on the right kind of shows that process. So when field maps came out, that greatly improved our data mapping. Our benefits were in hindsight that it would allow us to refine more of our attributes. So for example, we could consolidate the owner layer for our agency, such as Maryland State Highway Administration, Montgomery County Department of Transportation, Montgomery County River Authority, or Montgomery Parks. It also allowed us to create subtypes and specific domains to refine the information we have. Like for example, is this structure a boardwalk, is this structure a bridge, or is this structure a culvert? It also allowed us to improve our domains, which basically define, for example, structural material. What type of deck did it have? Did it have a wooden deck? Did it have a concrete deck? And also, like, what type of support structure do we have? So on this slide here, this is kind of like from collector to the field app. Basically, in our collector days, when we first started, we had 58 unique values for like a culvert material. And then we were able to reduce that down to 6. So the reason why is when we first started with collector, we kind of let the inspectors do their own thing. And they would basically say, okay, this is a concrete pipe. And they'd say, spell with a capital C, or lowercase c, or they spell it C-O-N-C. So that's what basically created this whole list. So we were able to reduced that list and we created down to 6. Brick, CMP, which is a corrugated metal pipe, VIP, ductile iron pipe, galvanized steel, HDPE, which is high density polyethylene pipe, and reinforced concrete pipe. And now Carter's going to go in and basically show you how we implement it and how to go through the forms and give us an example.
Yeah, so now that we had all this time to like really get all the data into a single consolidated layer, really think about subtypes, domains, etc., and really refine things, we fully take advantage of this field map smart forms. Where this was really beneficial was that we could eliminate too much information being held at the same view at a time. This decluttered the form, decluttered the data entry for inspectors, also allowed us to make things conditionally visible because there's certain attributes we had that were only pertaining to culverts that we obviously don't want to share when you're inputting information about a bridge. So that really streamlined the workflows for inspectors as we collect this asset-specific information, and hopefully made it a speedier, more enjoyable process for them too. Where we also invested in the data entry was acquiring a GNSS device for the inspectors, as you can see Brian showcasing here, and also iPads for all the inspectors. Not all of them had mobile devices. It's pretty important for them to have a device using technology, right? We can't really ask them to do something if they're working don't have an iPad. And likewise with the GNSS, why it's like really important to mention like how much trail we serve is that these bridges, boardwalks, and culverts are the connective tissue to those, and those are in natural areas with obstructed views at a time. So even currently, like we could have our locations better suited for where the bridges and other structures currently lie, and some of that is due to location inaccuracy of GPS, particularly when you're dealing with a tree right over your head. Where we made probably the greatest efficiency and time savings in this kind of step 2 process is the inspection assignments. Brian mentioned that we started with 200, went to 600, and then and in this kind of second era, even collected up to 800. In this process, like the inspection assignments evolved to the degree that they weren't really able, it's like building the plane as you fly it. We made the mistake of sometimes adding structures cross-county, missing structures that are part of the same trail. So on the left, it's really busy with the colors because there's just not enough colors in the rainbow to show how the 41 unique inspection assignments that were given out to our inspectors. But you can get the general sense that when there's a dot there, it's a color that's out of the ordinary, an outlier, that's a bridge that they're quite literally walking over and not inspecting and then having to return there later that month or the next year. And that's just a huge opportunity cost in terms of efficiency. And also when you see colors that are cross-county, these are ones where they're picking it up and driving by probably about 100 structures to then inspect something across the county, which is not really good use of anybody's time. And this is something that the inspectors kind of reported about and complained about and that they weren't really happy with. And this is something that they are very receptive to because this confirmed their biases, this confirmed their frustrations about the inspection schedules. And what we did to fix that was use k-means clustering, a special constrained variation of it that allows us to set a minimum and maximum. We set it to have 8 clusters because we had 4 inspectors across 2 years. So each inspector would get one of these colors per year, and the minimum and maximums allowed us to at least give them a minimum amount so they have enough work set out for that year, and that also the maximum so that they're not overburdened because as you can see, as we move south down in the county, there's a lot more densely compacted amount of counts of structures as compared to the northern part of the county. So we wanted it to be less of a burden and account for the fact that when you're walking across trails and you can hit 6 in a single day perhaps, you're not really afforded that luxury when you have to drive to and from. And we had some tangible time savings with this as well. The stats are that the next closest structure from before and after, the average distance went down by 0.4 miles each time, meaning that every time they went from structure to structure, on average, they saved 0.4 miles of walking or driving. And we completely cut out the cross-county issue, where the largest distance between two structures in the previous inspections were 14 miles, and now the largest distance is 2.5 miles. So that completely eliminated that problem. And now I'm going to take you through the web app and dashboard, where we're leveraging some of this data. And it's projected, so bear with me here as I figure out where to send it. So the dashboard we're using is in Power BI. Yes, this is an Esri conference, but we chose to use this for one primary reason being that we're using two systems. Our asset management system is where the inspections are occurring and thus the data is stored. Our GIS is the sister to that, where it's containing the locations. Both are important, and we need to be able to visualize and analyze both. Power BI has these capabilities, and I'm excited where Esri's making improvements on that front as well. But when working with this, we're able to see the counts of the inventory across all the attributes that Brian mentioned that are important to them, like the structure type, the structural load, the structural material, whether it recommended a repair immediately as part of the inspection, and also most importantly, having a map of these overall ratings, which is like the top level number that we look at for these structures. And the mapping is particularly important because when we actually do these renovations, the occurrence plate, the occurrence space. So it's a good opportunity to look for, as I try to zoom in here, are ones like over here in our Wheaton Regional Park, where we could perhaps only close down like a small portion of a trail or a certain small portion of park and find these 2 birds, 3 birds, 4 birds, 1 stone opportunities, because these structures are critical to the trail system. If you shut it down, that's a complete shutdown of that navigation lane. So where we can close down, like for example, these 3 right here, which I believe are on the same trail, that is a place where we reduce the impact on our citizens and also staff who have to navigate these for their own purposes. One of the advantages we had in here too is that we can navigate all the condition ratings that are given, whether it's the overall rating or any of these sub-ratings, whether it's like channel protection or cross beams, and visualize those. But to continue back to where this connects also with the Esri product that makes this even more helpful is that we have this table here that is just a raw dump of all the data. Contains like the notes and all of the condition ratings all the way to the right, and then you're able to sort by all of this information. But this data, as you can imagine, it's always going to have opportunities for improvement. We're always filling in more and more information. Some of the information here, a minority of it is probably needs to be corrected, and where we can do that and also gain additional spatial context is by leveraging the web application that we've integrated with the web app builder, which will be moving to Experience Builder once URL parameters are supported. Because the Power BI is able to construct that link with its expression language, not too different from Arcade, and then navigate to that specific bridge. So if we find one, we're like, okay, this is the perfect opportunity for a repair. Let's see how feasible it is or how much of a hurdle it is to get a renovation here. We can then look at it here on the map and have aerial, trails, streams, any other layers that they found to be important for maintaining the program, and also correct the QA/QC with some of this information, which you're immediately able to do in this application and start editing and fixing things on the go. And that's about all I really have to share about this project itself, and it's something that we're trying to inspire is being replicated across our organization for our condition ratings. We have to condition rate dozens of things, and this program is like the model that we're going to try to replicate for courts, retaining walls, bleachers, right? And those are currently being worked on with the same methodology as we speak. And just anything that is of importance for maintaining the quality, either for just the use case for the use of citizens or for the safety, like retaining walls. Because bridges and culverts, etc., are examples of both, where if you don't have them, you're missing out on the trail, and if they collapse under your feet, it's also a big problem for that to happen. So with that, I'll close it out for questions.
Go ahead.
What software are you using for your EAM site?
We're using I think it's Hexagon EAM, and it has some Esri integrations supported with it as well.
And is the EAM writing to GIS, or is it the other way around?
They're not writing to each other at all. That's actually something we're working on, because we essentially have to maintain two inventories simultaneously, which is a huge pain point. But we're working on integrating the two as we speak, and that's something I'm pursuing meeting.
One just note is that that's the Info EAM, formerly Info, right?
Yes, formally Infor as
We had
we
a
said.
lot of success using FME server to ETL between Info EAM using their web services and our GIS database.
Yeah.
So
Yeah. And we're thinking of kind of doing the same idea except with Azure. So the same strategy.
Well, my question is, can you describe how are the inspectors doing the inspections? Are they doing it all in field maps and then you're ETLing that back? Or where's the line between what tools your inspectors are using on the ground?
Well, they use the laptops, and the information goes right into the laptop. Then the information usually goes right into the EAM through the link, and then it goes into the Power BI. Updates once a week, and then anybody can access the Power BI, and then that's when we do our sorting. So
Yeah.
it's kind of
Yeah, EAM has a digital work mobile app that we try to get them to use. We've let them to water with the iPads. Some of them still elect to use the desktop environment. And the data is collected in the EAM for the inspection ratings. And then we try to make our GIS the official, for everything that's inventory-wise as well. So it's kind of like piecemeal at the moment, but this is why we're aspiring for the stuff to be better integrated.
So field maps is just for collecting the initial location?
Yeah, the locations and anything that's static. And then the inspections are for anything that's like condition, where it might change over time, where it's going to be valuable to have that data like every 2 years. You see that degrade over time.
And then the information in the field maps gets into GIS, and we bring it up once a year approximately to update our desktop into our database.
Yeah.
So how do you incorporate the changes to each of these points with your construction or your maintenance crews? You kind of explain that process.
Yeah, well, basically, what happens is, like I said, it goes into Power BI, and then I open Power BI, or someone else would, and we would QC the information, and then you basically take all the ratings of number one, and then we have to prioritize them, because we really can only replace 4 to 5 a year, and right now we have 46 on the list that needs to be replaced. So, I mean, that's beneficial too, because we could go to our county council then and say, hey, look, we're not really getting enough budget to help, get these repairs done, and then you can actually see the see where the numbers are and how it gets spent. So that's kind of how we want to go in the future too, so we can kind of beef it up, you know.
So where I'm assuming there's some sort of closeout survey once the construction is complete.
Yes, it is. Well, we used to call it a MOM, maintenance and operation manual, but sometimes we go out and we have a as-built survey done, or we would basically have our project managers go out and they would take the information and we put it into our EAM system, and then when the work orders get generated from the asset, we'll have all the current information in there.
You mentioned this earlier, but I didn't hear what you said. What was the method that you used to cluster points?
K-means clustering. The specific package was done in Python. It's called K-means constrained. It's a variation of the sklearn K-means constrained algorithm. And by the way, like, not to scare anybody off who doesn't code, but you could probably pick this up in less than a couple hours. The developers of these packages make it super, super easy. And I'm pretty sure there's comparable Esri tools for those who like to use Pro to do the same operation.
These are all great questions. Appreciate it. Sure.
We're doing a similar project for irrigation district in Mexico, and we're at the point where we're trying to select unique identifiers and unique names for each of the structures. What did you guys do about those?
Yeah, that's an interesting question. So the kind of the full scope of the story is they with the paper process, they would literally put plates, bronze plates? Yeah, metal plates that they had like a 3-character code of the park that is unique, and then a digit. We've kind of carried through that and started using a similar asset ID born from our asset management system. And yeah, this has been a pain point because now we're maintaining 2 unique identifiers when we really only need 1. Yeah, that's basically how we've been doing it. And those get created and they're supposed to be unique as they get entered. And we've also automated that as well, because it's with it being a semi-manual process with some of the things before, it's always like it's an odd problem to have. Like, well, let me look up the next number, and you have to do that for every single asset, which is a little ridiculous, but now it's automated.
Yeah, sometimes the numbers get out of whack. Obviously, when we originally did it, we would start at 0 down at the bottom, and we'll work up our trail or something like that. So now when we have to add new ones, like if this was a 16, this is going to be a 17, which is a little odd. But with this system, you know, you just do it as you press the button, and the guys know where to go. They know the unit. So.
Yeah.
Also use this for like roads or trails or other structures.
It can be used for everything. And we want to use it for retaining walls. We're going to start using it for playgrounds, bleachers, and then basically, you know, obviously you have a unique numbering system. You have to come up with your own, and then everything goes into EAM. So, and then when we go and look at the ratings, all of a sudden we're going to have all our assets in one, and then we'll see all the red. So then when we go over here and we know we got to do something here, we're going to know, oh my God, this playground needs something, or this water line needs something. Or then we can always put all these projects together instead of having them all done piecemeal.
Yeah, and like with our trails and to be determined with roadways, we have an inventory done as well. We should have segmented them by park boundary so that they're somewhat distinct. Some of our trails span literally like dozens of parks with our stream valleys, so it's important to recognize some of those as independent assets, and because we're not going to renovate 14 miles of trail, which is our longest trail. Yeah, and like Brian said, we want to get condition ratings on everything. Long-term vision-wise, kind of the idea of Christina, right beside you, is to have ratings for everything and summarize those for the entire parks. So we can look at that with like equity equity lenses or any other type of analysis, because one of the big things that we've used to prioritize some of these renovations is where existing projects are occurring or planned, because those are our two birds, one stone. It's a lot easier to replace a bridge if they're also replacing a playground there. So in parks that are rated poorly on a multitude of assets, those are great opportunities for a project.
Whole park renovations and
Yeah.
capital. And then the different funding comes from different piles in our CIP too, so that helps us identify where the funding's